Welcome back. In today's video we are going to talk about electric motor, and this electric motor is working on the principle of electromagnetic induction, and further in electromagnetic induction, mutual induction. So in an electric motor, as it is being said, there used to be two coils, okay, which will be connected with a power supply with a variable resource test, and this will be primary coil having N turns. Suppose current is passing through it as I1, and there will be a secondary coil which will be connected with a galvanometer, so that we can see that an induced EMF is set up in the secondary coil, which will be of N2 turns. Take it as right. So in mutual induction, by following electromagnetic induction principle, it states that if there is a change in current in a coil, in a primary coil, there is a change in current in primary coil, it will induce an EMF in the secondary coil. Okay, this is the principle of mutual induction. And we know that mutual induction unit, that is SI unit, is Henry, which is denoted by capital H. Okay, so we can say that it is based on Faraday's law of electromagnetic induction, that EMF is induced in a coil, nearby coil, when the magnetic flux linked with the first coil, it is changing. So there will be a magnetic flux, you can say magnetic flux due to change in magnetic field, even self-induction will be taking place. Okay, so the change in magnetic field, magnetic flux, when it is changing, the magnetic flux will be change occurs, and due to current change in another coil. So there will be a current change in another coil, magnetic flux change also, and induced EMF will be set up in the secondary coil. This is the principle. Okay, this is the principle. Now how it works? See, this figure is given here. So it is the actual design of a motor, in which there used to be primary coil, secondary coil. Magnets are there. Sometimes the coil will be rotating and the magnets will be static, and sometimes this magnets will be rotating and coil will be kept as static. So both cases are there depending on the speed of the electric motor. So when the word electric word is used, it means electrical supply. It needs an electrical supply to work. Whereas in generator, mechanical energy is being converted to electrical energy. In motor, electrical energy is converted to mechanical energy. Okay, right. It means that shaft will rotate. Okay, how it works? So it is working by placing two coils, number one coil and two coil, numbers another two, second coil, close to each other. They are close to each other, but physically they are not touching each other. Okay, and when current is passing through first coil, is changing, when we are making the current to change in first coil, it makes the magnetic field also to change. Okay, so due to this change in current in first coil, the magnetic field linked with the second coil also changes. The magnetic field is getting linked with the secondary coil. Okay, it gets linked with the secondary coil, and then magnetic flux, change in magnetic flux takes place, leads to magnetic field. And this varying magnetic field magnetic field induces an EMF. Induces an EMF in the secondary coil. Okay. So there, as per Faraday's law, there is a formula, that is EMF induced. Okay, that EMF, electromotive force, it is induced in a coil which is proportional to change in current, and the constant of proportionality is N, which is called mutual inductance. Okay, mutual inductance. So change in current.
Sir. Thank you.
Right. So what are the factors which can affect mutual induction? We must know. Okay, a little bit description will go for next slide also. Here also some detailed, it is taken from Google only. I have not made it. It's from Google only, reference is being taken. Okay, from .in, some images we have taken just for reference. Okay, not for any commercial purpose, for academic purpose. So we were discussing about factors affecting mutual induction. Mutual induction. So which are the factors? The factors are, first, number of turns of coil. Number of turns in coils, that is N, N1 and N2. Okay, N1 and N2 both. Then second one, it is distance between the two coils. Distance between the two coils, but they should not touch each other. So distance between the two coils. Similarly, area of cross section. Area of cross section of two coils, both coils. Another one, very important, that is core material. That is called core material. Sometimes it will be used as air cored material, so air only will be there. But if soft iron core is used, so change in magnetic flux takes place more. Okay, so more current can be induced. So core material, as an example, it may be air also, or it may be soft iron also. Soft iron also it is used, and it is used for increasing in mutual induction. And the fifth one is orientation. Orientation of coil. Okay, orientation of both coils. So these are the factors which are affecting working of mutual induction in electric motor. We also let us know some of the applications, where applications are there of this particular concept of electric motor. So we can say that in transformers we go for step up or step down transformer, correct? Okay, so step up or step down. Voltage transformers, voltage transformers. Then second one, nowadays in present generation, in present technological advancement, we even go for wireless some power transfer systems. Okay, systems for power transfer. And some of the devices nowadays it is available even in electrical vehicle charging. Okay, this is also called as inductive charging. And also very important in all electronic circuits. Like radio or TV. Okay, so electronic circuits, in that also we are using this electric motive principle. So we have seen that how mutual induction is used for an electric motor to work. Okay, and this particular electric motor is also very important. We need to understand, and it is a very important component, or we can say that device which we are using in our home. So I hope everybody has understood about mutual induction and also how an electric motor works. So thanks to all of you.